So in this part, we'll talk about the linear momentum of a particle, of a system of particles, and of the center of mass. So we'll talk about then the rules. First, the linear momentum is given by the product of the mass by the velocity. And you know that the velocity is a vector quantity. This is why the linear momentum is also a vector quantity. In order to find the value, بما أنه we don't have addition, then P equal M times V. So هيطلع عنا then in this case the linear momentum is in kilogram meter per second, since the mass is in kilogram and the speed is in meter per second. Now let's do here an application. So calculate the linear momentum of a 15-gram bullet moving with a velocity of 315 meter per second to the right. We have the mass, we have the speed. So in this case, you can find the linear momentum. Then we know that P equal M times V. We have the mass is equal to 15 times 10 to the power minus 3. It's in kilogram times V, which is equal to 315. So we'll have as answer, it's equals to 4.725 kilogram meter per second. Now, if the question was to find also the vector P, the linear momentum vector, then since it's moving to the right, so we can take it as the x-axis. So it will be in terms of I vector. Then P vector, it will be equal to 4.725 I vector. This is the linear momentum in terms of vector. Now, if you want to talk about the linear momentum of system of particles, we know that if you have, for example, here عندنا 30 particles, but the important is the velocity are not collinear. They have different direction. So in order to find P of the system, معناتها بيطلع P1 plus P2 plus P3. Okay, so هيدي P system. Now إذا بدي كفيها, we'll do now a substitution. So as substitution, it will be M1V1 plus M2V2 plus etc. الشيء اللي كتير مهم ننتبه له, we must very much pay attention that this is V1 vector, this is V2 vector. So this is why I can never say that P of the system equal to M1 V1 value. We have addition, and the addition here is an addition of vectors. So we can never use this part. So as application, how we should do it. So let's suppose we have to find the linear momentum of system of particles with masses m1, m2, and m3, each moving with the following velocities. We have v1, we have v2, we have v3. So in order to find P of the system, P total of the system, we'll say that P of the system is equal to P1 vector plus P2 vector and plus P3 vector. And in this case, when we continue, we have P1, it's 1 times 3i, okay, plus P2, which is equals to 3 times 2j, and the plus between a bracket 2 times minus I plus 2j. So we continue the calculation and we'll have as answer, it's I plus 10j. Now, if the question is also find the value, then since it's the vector in terms of I and j, in order to find the value of linear momentum of the system, so it will be equal to radical px squared, we have the components, px squared plus py squared, which will be equals to radical 101 kilogram meter per second. So this will be the value. Now, what about if we want to find the linear momentum of the center of mass of system of particles? So in this case, we will see that the P of the system is equal to P of the center of mass. This is what we call PG, the center of mass. How can we verify this? So by using the position vector of the center of mass, which is equal to M1 R1 plus M2 R2, or this is the position vector. Okay, so by deriving this equation, we know that dr over dt, which is the derivative of r with respect to time, this is what you call the velocity vector. So by deriving all this equation with respect to time, we will have as answer drg over dt, which is what you call v, the velocity. And r1, if we do dr1 over dt, the derivative of position vector, it will be v1 and etc. We continue here by cross multiplication. This is what we call the total mass, m of the system. So m of the whole system times Vg, this is what you call P of the center of mass. So هيطلع عنا here equal m1 v1, but we know that m1 v1 plus m2 v2, this is what we call p1 vector plus p2 vector. And this is what we call P of the system. So هيك بنكون بيهنا that P of the center of mass of system is equal to P of the system itself.